In this video, we're going to be doing chemistry problems with systems of equations. The word problems are pretty lengthy at times and have some complicated parts to it, but it's something that you can do with some practice, and I think we'll get good at that hopefully throughout this video, and will help you for the homework lessons that you're going to have. All right, the first thing that we need to concern ourselves with or to look at is just what we mean by the amount of a solute. Okay, so we may have a 12-gallon container that is 50% salt water. Okay, what we're going to do on this is to find that amount of salt or the amount of water in there. We're going to take the percentage of that and multiply it by the volume that's given. Okay, so in this case we would take the percentage, 50%, and we would multiply that by 12 gallons, or numerically wise that would be 0.5. 50% is the decimal point 5 times 12, so we would end up with 6 gallons of salt and 6 gallons of water, being that it's a 50-50 even split. Okay, so for the next one, we'll see down here we've got 48 liters of a 25% chlorine solution. So it's 25% chlorine, 75% water. And we would take the 48 liters, well, let's do percent first. So we'll do the percent, 0.25 times 48 liters. So we would do that 0.25 times 48, and we would get 12 gallons. And because it's the 25%, it's 25% chlorine, so that would be 25 gallons of chlorine, 25 liters of chlorine, and then it would be the 36 gallons of water if we did 0.75 times the 48. The big thing to remember, the amount is always percent times volume. Percent times volume. Okay, the amount is the percent times the volume. All right, in this third one, we've got 120 milliliters of a 40% alcohol solution. So we've got 40% as a decimal. That's going to be 0.40 times 120 milliliters. And if we did 120 times 0.4, we would get 48 milliliters of alcohol. Okay, and that is the amount of the alcohol. The key here is, and I'm going to say it lots of times, amount. The amount is the percent times the volume. The amount is the percent times the volume. Okay, I gave you these three examples for us to practice that part of it because that's only one small component of the chemistry problem, but it is a very important part that we've got to understand. Amount is equal to percent times volume. Okay? When we write our two equations, we will have two variables. It will be two unknowns, so we have to have two equations. Equation number one will be the volume of the volumes of each solution. Okay, you may be given a 10% solution and a 75% solution. You're going to have a volume of each of those. Typically, in that case, we're going to use the volume of the first one added to the volume of the second one is going to equal the volume of the third one. That's the way equation one is set up. Typically, the volumes are going to be X and Y for the gallons of the first one, gallons of the second one, gallons of the third one, or milliliters of the first, milliliters of the second, and so on. Okay, so typically our first equation will be something like X plus Y equals, and then you'll be given the volume of the third solution that they're trying to create. The volume that's here in the third one will be, again, the one that the chemist or the lab technician is trying to create. Okay, now equation number two. Okay, so typically our first equation is going to be X plus Y equals the new volume. and that's going to be given to you in the question. Our second equation is going to be the amount of the solutes in each one. And what is amount? Is percent times volume. So we're going to have this percentage times the volume here, and the percentage times the volume here, and that's going to be the percentage times the volume there. That's the amount. The amount of the solution is percent times volume. So this may be something like 50% X and 20% Y. Okay, and we'll put those in as decimal numbers. And then over here we will be given what this new volume is, and that would be the percent times whatever that new volume number is, and this one will actually become a numeric value. Okay, so we'll set those equations up in that format, and then we'll use the elimination to solve. And we'll walk through each of those steps on the two examples in this video. All right, so here's our first example. We're looking for what we do every time on a word problem is we're going to start at the end, and it's asking how many gallons of each solution must be combined to make the 75% solution. When it says each solution, as we read through, we're going to find that there's two different solution or concentrations of solutions that we're going to have to find. Just looking at it right quick, one of them is a 15 and one of them is a 90. Okay, so we'll go through that example and make sure we get that. Okay, but the question again is, what's the gallons? How many gallons? And gallons is a measure of volume. So of the 15%, we're going to say X is the volume of the 15% solution, and Y is the volume of the 90% solution. Okay, so we've assigned our variables to answer the questions. Read the questions at the end and assign your variables to make sure they answer the questions, which are what is the volume of the 15% solution and what's the volume of the 90% solution. Okay, so the pharmacist wants to make 200 gallons of a 75% solution. Now I've got the little buckets here drawn to kind of help clarify this and what we're looking for. We're going to take some of this one and add it to some of this one and create this new solution. And that new solution that the pharmacist is trying to make is 200 gallons, and it's a 75% solution. Okay. Hopefully you can see that in the wording of that first sentence. Okay. The solution is going to be made from a combination of a 15% solution and a 90% solution. Okay. So we're going to have a 15% solution and a 90% solution, and the volume of each of those are going to be added together. So the volume of the 15% solution is X, and the volume of the 90% solution is Y. So basically at this point, we have the first equation written right there. We have X plus Y equals 200. The volume of the first one added to the volume of the second one equals the volume of the new one that we're looking for. Okay. Now we're going to take the amount. The second equation is the amount of the solute, and we're going to remember that it's the percent times the volume. So the percent is 0.15, that's 15% as a decimal, times the volume, X. We're going to add that to 0.9 times the volume, Y, equals, and we need to do the calculation on this one. We need to do 200 gallons, and we're going to multiply that by 0.75. So on this case over here, we're going to take this volume and multiply it by its percentage, the percent times the volume, and in this case we get 150. Okay, that 150 has to be a numeric value there. It won't have a variable with it. You have to do that calculation. It's the percent times the volume right here that gets me that 150. Okay, that's where that comes from. All right, so now we've got our two equations written, and we're going to have to use elimination to get them to solve and to come up with our answer. Okay, so what I'm going to do is I'm going to multiply by 100 on this bottom equation, and that's going to end up moving the decimal 2 places to the right, but it allows me to get rid of the decimal in the equation. So if I do the times 100 across this whole equation right there, that's going to move the decimal over, and I would have 15x plus 90y equals 15,000. Okay, that's moving the decimal 2 places over. Now, to create the opposite that I'm looking for, I want to create a negative 15x right there. So for that to happen, I need to multiply this equation by negative 15 so that that creates the negative 15 opposite that I'm looking for. So negative 15 times x, negative 15 times y, and then negative 15 times 200 is going to give me negative 3,000. And because I've created the opposites now in the x variables, and those opposites are there, I can add the equations. We do our normal procedure on elimination. We're just going to add those now that the opposites are there. And that's going to end up giving me 75y equals 12,000 when I add those. So 12,000, and I'll end up doing the division by 75 on both sides. So y comes out to 160. Now let's remember, what does y stand for? Y is the volume of the 90% solution. So that's 160. What are we looking for? Gallons. So that's 160 gallons. All right? And that would be our y variable, or the volume of the 90% solution. So now we can put our y variable, our y value right there, because that's in our equation. And I will take that and go the x plus 160, that's our y value, equals 200. And we do our subtraction of 160 on both sides, so x is going to be 40. And what is x? X is the volume of the 15% solution, so we have 40 gallons. Okay? And that would be our process for working those equations. And there are 2 answers. Okay? Got one more example that I'll walk through in this video, and hopefully it'll be helpful for you to be able to do the work on the assignment if you have any questions. All right, so let's look at this one. We go to, again, the question at the end, and the question at the end says how many milliliters of each solution to make the 60% solution. So we're going to assign our variables. We're going to use a 10% alcohol and a 70% alcohol solution. So the volume of the 10% alcohol solution is going to be x. The volume of the 70% solution is going to be y. X, the volume of the first one, plus y, the volume of the second one, is going to be, according to the question here, the chemist wants to make the 180 milliliters. That's the volume of the new one here, which is 180 milliliters. So x plus y equals 180. That's the first equation. Second equation has to do with the amount of the solute. Again, this is a 10% solution, which has a volume of x. The 70% solution has a volume of y. And then we want a 60% alcohol solution for our new solute. Our solution they're making is only 60% alcohol. All right? That second equation, remember, is going to be the amount. And the amount is always going to be the percent times the volume. So I'm going to have the percent 0.1x plus 0.7y equals, and now we'll do that percent times volume, 180 times 0.6, which is 108. Okay, we can do that over here to the side. For that 108 value, we're going to take the 180 milliliters and multiply it by the 0.6 or 60%, and there's where the 108 comes from. That's that amount of alcohol in the new solution. Okay, so that's where that comes from. That's the one tricky part that most students kind of struggle with finding what that number is, okay? We only need to multiply this by 10 so that we move that decimal one place to the right. We don't need to multiply by 100 because we only are going to move the decimal one place. So doing that multiplication is going to get me 1x plus 7y equals 1080, multiplying by 10, right? Now the good thing about the way this one's set up is I need to make a negative 1x right here. Well, I've already got a positive 1x in my original equation, so all I'm going to need to do here is multiply by negative 1 and do that negative 1 multiplication across there would get me negative 1x minus 1y and minus 180. Okay, we do have the opposites created now in the x variable, so that when we get that, we are going to be able to add those two together, and we would get 6y equals, and then we'll take the 1080 and add the negative 180 to it, or subtract 180 from it, and we get 900. Okay, that 900 then gets divided by 6, and we have y equals 150. Again, y, the 150 milliliters, is the volume of the 70% solution. Okay, and we've got our answer to the y variable. We'll take that value and put it back up into this equation that has to do with the volumes, which is the easiest one to put it in. So you would have x plus 150 equals the new volume 180. We'll subtract 150 from both sides. So x is 30 milliliters, and that would be the volume of the 10% solution that we would have for our two answers. If you wanted to plug those values back in, plug the 150 in for y, plug the 30 in for x into this equation, and do the 0.1 times 30 and the 0.7 times 150. If you add those two numbers together, you should get 108. If you do, you've got the correct answer. Those are chemistry word problems. Again, your first equation is volumes, your second equation is the amount of the solutes, and the percent times the volume is that amount. The amount is percent times volume. Good luck on those equations and questions, and hopefully we'll be able to work these through on the flashcards page without any issue.